Hello. If you're trying to use AI APIs, I thought it might be useful to, especially if you're new, if I went through some of the terminology and it might help you just use them a bit better. So I'm going to go through the Anthropic API overview page and anything on there that I think is useful for you to know, I'm just going to go through it. It's not going to be very structured. So you've got models. What's a model? Each of these companies, so you've got Anthropic or Gemini or OpenAI, they're releasing different models. And these models are the foundation models like ChatGPT. And inside ChatGPT, you've got the models like GPT-4, GPT 3.5, o3. You've got Claude Opus, Claude Sonnet, you've got Google Gemini. So all those terminologies that you see, those are the models that are underneath the interfaces like ChatGPT, like Claude. All right. And so you can see you've got different models here. And basically what they're trying to do, these companies, is they're trying to make the most intelligent, the most useful models that they could possibly make. And you can see that they're increasing in numbers. That's because it's good marketing, right? Claude Opus 4, it's like, oh, it's better than Sonnet 4. And yes, a lot of the time it is, but it depends what you're trying to do. And that's why they keep these models available. And a lot of the times, because these newer models are using much more credits and have larger context window, we'll get into that in a second, because these models are better in certain use cases, they're going to be more expensive to use than some of the older models. So for example, if you want to use GPT 3.5, it's a lot cheaper to use than GPT-4, depending on what you want to use it for, right? Okay, so that's the models. Then Anthropic API, what does this mean? So what this means, this Claude Opus 4 20250514, what this basically means is this is the exact name that you would copy, Control C or Command C if you're on a Mac like me, you would copy that, and when you're making an API call in your code and it says you've got to specify the model, this is the name that you would use. So I'm not going to talk about AWS, Amazon Web Services, Bedrock, or this one over here. I'm not going to talk about that. Okay, I'm going to block that out with my face. What we're talking about here is if you want to use these models in your code, in your apps that you're making, this is the name that you want to use for specifying which model to use. And if you wanted to use Claude Haiku 3.5, you would come and copy this and you would use that in your API call. So you can switch out different model names, but this is the technical name that you'd want to use if you want to use it in an API call. Let's move down, all right? So model aliases. What this is not to be confused, right? This one is a very specific version. So they may tweak it, right? They may tweak, if you're using this in your code, this one, Claude Sonnet, and it's got 2025 02 19, that's the date, right? If you're using this one in your model and you've got it so perfect, so your prompt that you send through is really perfect and you're getting the exact output you need, and then they make an update to the model and it ruins your code, that could be very frustrating. So they let you have the exact version of the model. So you can keep using that one if you want, you can keep getting consistent results. So model alias is just a way of having the blanket for this model. So it's a shorter way of writing it if you want to write it out. Okay. Model comparison table. Okay, so there isn't much for us to go through in terms of the actual models on here, but what this table is very useful for is, let's say you're thinking, which model do I actually want to use for my app? Okay, so you want to use the API in your application and you don't know if the task that you want it to do is too complicated or not complicated enough to use the most expensive model. So you'd come here and you'd think, okay, what do I want it to do, right? maybe you want you want the response to be incredibly fast. You don't want any delay, no latency whatsoever. So you'd come here, description, our fastest model. Okay. So maybe instead of using Opus 4, which might take a while to get the response, maybe I'm fine with a slightly less detailed response, but it comes out super fast. So maybe you'd use Claude Haiku. Okay. You can see the different strengths of the models. Okay. So high intelligence with toggleable extended thinking. I'm going to go through what extended thinking is in a second. But yeah, you've got the strengths. Notice they don't have weaknesses on there, which is interesting. Multilingual. Okay, so that is what it says, which is, can it talk French to you? Can it talk Spanish to you? Okay, if you notice, all of the models are multilingual. And what that basically means is that they've been trained not just on English language, not American, not English language text and input on their training data. They've had Spanish, they've had French, they've had all the different types of languages in there. Probably not some of the obscure languages, but most of the major languages will be in there. Vision. What does vision mean? Vision means you can send an image. So as part of your input, you can send an image. If it said no, there was no vision, you wouldn't be able to send an image to the model for it to look at. When I say look at, what you see as an image, so you see an image of me here, but actually what the computer sees is a very long string of numbers. So computer vision means it can take those strings of numbers and it can do things with that. Extended thinking. This is the best way to explain this very simply is in the simplest form, non-extended thinking would be if I type, please tell me about the Eiffel Tower, and I send that, it's just going to immediately give me the response. The output is, the Eiffel Tower was built in da-da-da-da-da. It is in Paris, da-da-da-da-da. So it's not done any extended thinking. What extended thinking is it loops over itself. So you ask it a question, the output from that input is then fed back into the model and then looped over itself, and so your question gets broken down into 4 parts. Those 4 parts are then looped back around, maybe that goes into 8 parts, and then that's all brought together again into a final output that's then sent back to you. So you get a much more detailed, a much more accurate, a much more considered response. Priority tier. So this is if it's really busy, can you basically get the compute when you need it, even when there's millions of people? Do you remember when ChatGPT was first coming out? It said, due to how busy this is, we're limiting the responses. Okay. So API model name, we've just talked about that, which is if you want to use it as in a call, in an API call, HTTP request, you'd put this particular name, make sure you spell it right. Comparative latency. I really like this because it's comparative. So we talked about the strengths up here, which is our fastest model. Well, comparative latency here is just how fast is it compared to the other models. So if I want deep thinking and I don't care if it's fast, maybe I'll use this one, moderately fast. You know, notice they're blowing their own trumpet here. There's no slow written. So you've got fast, fastest, moderately fast. They could also flip this, so they could say slowest, less slow, least slow, couldn't they? But they're not going to do that. Context window. What does this mean? This is so important for you to know when you're talking about AI. Context window is how much information can you send to the model. So 200,000, right, is tokens, not words, tokens. And 200,000 tokens is about 150,000 words, right? So in all of these models on the API, you can send 150,000 words. That is a lot of context. And maybe this is too deep for this video because I'm just explaining terms. But basically what it does with your words is it turns it into numbers. So it turns your word, let's say dog. Dog becomes a number, and a number gets put on the graph. So it's called a vector. So if you imagine a graph, X, Y, Z, so you've got the three-dimensional graph, well, the coordinates of dog on the graph are here. Just bear with me. They're here, and then the coordinates for cat, X, Y, Z, maybe they're here. So it can work out the distance between cat and dog, or cat and dog. It can work out the distance and know how closely related they are together, right? And that's how it understands context and how it understands what words you're actually saying. So the context window is the words that you're putting into the API, into the model. And the way that it knows which words are related is because it turns them into numbers on a graph. And then it can tell how far away certain numbers are on the graph. So dog is here, cat is here, right? But maybe you're calling someone a dog, and that's slightly different than calling someone an actual dog, right? And so the words around, like when you say the word dog in a sentence, the rest of the words impact it. So the context window is the total information you're sending into the model. But they don't use 3 parameters. So X, Y, Z is 3 parameters. And that's quite useful for us to understand. X, Y, Z, it's 3-dimensional space. We can understand that, this cup is here in 3-dimensional space. It's got depth, it's got height, it's got width. I understand this. These computers can go so fast, they can consider, usually it's 128 dimensions. So it's not X, Y, Z, it's X, Y, Z, A, B, C, D, E, F, G, 128 dimensions. It's actually unbelievable. And so dog with 128 dimensions is related to cat here, just like king and queen may be this close, right? But rain, there's a lot of different rains. Rain is slightly different, but the model measures the distance between the words, and then that's how it predicts what the next most likely word is. Okay? There's another video in there. Sorry for that weird description, but that's basically what you need to be looking into is how do these models actually know through vectors which words are the next most likely one. Okay? Max output. Let's move on. I'll do another video on context window because I didn't explain that very well. Max output. So you've got inputs and you've got outputs. The input is what you send to the API. The output is what the model sends back. And in your API call, you can choose how many tokens it sends back. It costs you money for every token output. Okay, so 64,000 tokens here is what Claude Sonnet 4 can send back to you. So you can put 200,000 in and you can get 64,000 out maximum. If you notice, it's quite a large difference between Claude Sonnet 3.5 and Claude Haiku here that can put out 8,000 tokens, and these ones which can put out 64,000 tokens as output. That's a lot of words. Okay. Training cutoff data. What this means is that, so it's when you put something into the model, so you put an input into the model, right? It's not going out there and learning straight away. What they do is they feed these models in the very beginning. It's called the training phase. They feed these models billions and trillions of pieces of information. And they train it in one go. And then what they get at the end of that is an equation. So they've got the training stage and then they have an equation here, right? And the equation is what takes your input, runs it through the equation, and then gives you an output. But what that means is this equation, once they've got it, doesn't change. And so this one, for example, March 2025. What they're saying there is the data we collected to train the model, the data stops at March 2025. So if I don't give the model access to the internet and I ask it a question saying, tell me what happened in April 2025, the model will hallucinate because it doesn't know what happened in April 2025 because the data that it's got, that it's trained on, stopped. If I asked it what happened in January 2025, there's a good chance that that information is in the data. So that's what training cutoff means, training data cutoff. There's a specific stage where they're training the model and then they get the equation that takes your input and turns it into an output. Model pricing, okay. This is where we get to the actual maths of how much it's going to cost you to do certain things. So you've got MTOC. Guess what MTOC means? MTOC is million tokens. So for $15, you can input to the model 1 million tokens. And given that we can send 200,000, yeah, that means you could send 5 maxed out context windows for $15. Usually you're not going to be doing that. You'll probably send maximum per thing. You'll probably send 1,000. So let's see. So for if you're sending 1,000, you'd have to divide 15 by 1,000. So let's do 15 divided by 1,000. So it's less than 15 cents. It's so cheap, these things. So cheap. So for one and a half cents is how much it is per request, right? It's so cheap. Oh, we're all screwed. And that's for the most recent model. All right. Intelligence for nothing. It's really crazy. $75 per million tokens for output. Okay, so that's a bit more expensive. So what that's saying is you get charged to send and you get charged for the output. Right? So you've got to be careful when you're making your API calls and you're doing your testing that you don't run up some large bill. So a lot of people are getting in trouble because they release an app. You see all these vibe coders. They make an app and they put it out there and they've got their API keys which are connected to the model. And then users come along and start using their app. Yeah, and for every time a user uses the app where it calls Claude, it costs them the input tokens and the output tokens, and you can very quickly run up a large bill, especially if you vibe coded something and not read through your code. You don't know if the model's accidentally created a loop that means when you push this button, it's going to make 1 million API calls without you knowing. Yeah, imagine getting a bill from Anthropic. There's obviously limits, but imagine getting a bill for 50 grand that you have to pay because it's not like you didn't use it. You did use the model. Yeah, so you got to be really careful with that. But that's what MTOC means, which is million tokens. So if we come down here, Claude Haiku 3.5. This is the model that I'm using in Cursor most of the time. And that is 80 cents per million tokens. That is unbelievably cheap for input. Okay. This is an interesting one. Cache hits and refreshes. So one of the ways that they're saving developers a lot of money is by allowing you to cache certain information. So if you're regularly using the same input, you can cache certain inputs so that it doesn't cost you as much to send that information to the model. Okay. Anything else interested on this? Oh yeah, cache write. So cache hits is where, I'll start from this side actually. 5 million tokens of cache writes, sorry, let's explain what that is. Cache writes is you send the information you want the model to store. So to store 1 million tokens of useful information that you're going to come back to later costs you $3.75 here, right? So that information is stored, okay? Then cache hits, if you notice, those tokens then are much cheaper for you to send to the model than here. It's actually 10x cheaper. It's 90% less to go and hit the information that you've already paid to store there. So if I was a developer and I was constantly using the same information, I would pay a bit more to cache that information, and then I would save 10x hitting it over and over again. All right. So you've got input, cache, and you've got output. Let's have a look down here. Migrating. Great. So we got to the end. That's basically an overview of what the different API terms mean. So you'll have to excuse me for my bad explanation of what the vectors were. But if you just wanted a little chatty way of going through what the APIs are, one just very important thing for you to remember is if you want to use the model, it's always very confusing to find the names. But you just want to find the Anthropic API and use this particular name in your API calls. And then be very, 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 very careful that you don't make a loop and end up spending $50,000 on your app. All right. If you like this and you want to see another video talking about AI, please click here. Thank you.